Welcome to our notebook on hypothesis testing. The objectives for this notebook will be to know the difference between a null and alternative hypothesis, as well as learn to write your own set of hypotheses for testing and how to do so within Python. So first we'll import the necessary libraries. We'll import matplotlib.pyplot as PLT. That will just be for our plots. Import numpy as NP. That will be for quick numerical analysis. From SciPy, we'll import stats, which will be for statistical analysis, and then we'll also import math, which will just give us some extra functionality in regards to doing some basic math. So we want to come up with our first null hypothesis. So let's say that I claim that I can use mystical abilities to predict the outcome of coin flips. You don't think that I can, so how can we test it? What we do is we conduct an experiment in which I call 100 coin flips. And when we do that, I get 57 correct. Now our question is, am I special or not? So with this in mind, that I got 57 right, let's pause and think, what is the null and alternative hypothesis given what we have here, given the data that we have here? Our null hypothesis should be that I'm not special. My true rate of flip prediction is actually just 50-50, that every time you flip a coin, I have equal chance of getting it correct or incorrect. And even under this hypothesis, I could get 57 out of 100 right. So we want to determine, did I get lucky and get 57 by random chance, or am I truly mystical and can predict above the 50-50 chance? The alternative would be that my true rate of flip prediction is actually greater than 0.5. So that I actually can do better than a 50-50 guess. And the thing that we're measuring from the experiment, or our test statistic, which will allow us to decide whether to reject or accept the null, will depend on the number of correct flip predictions out of 100. Now, if the null hypothesis is correct, the test statistic is binomially distributed, with parameters n equals 100, number of flips, and p equals 0.5. That is, if we repeated this whole experiment many times, kept flipping 100 coins and seeing how many we got correct, we would see such a distribution for all of the results. So if the null hypothesis is correct, how likely is it that I would get 57 or more coin flips correct? That's, by chance, the question that we're trying to ask. Before we check, we want to put a marker and say anything above this marker or below this marker in regards to the chance of me getting a certain amount correct will convince us that I have ES.